Hi, I'm Zarif. I will be demonstrating our project Keep Your Distance on behalf of our group PA 2121. This project was developed for our client Ashok Menon. The aim of this project was to detect objects through everyday use cameras and to be able to measure distances between them, collect data, and generate some charts for reporting. The scope of our project was to detect humans only, with the understanding that this system will be extended later to incorporate identification of other objects and distance measuring between different objects. The key point to be highlighted here is that the cameras used will be regular cameras. Examples include CCTV cameras or, in our instance, laptop webcams that do not have any spatial capabilities such as depth measuring. Our team has developed a web application to tackle this problem. We're using HTML, CSS for designing some simple interface and using JavaScript and frameworks such as P5, ML5, and Charts.js to implement the solution. Our product starts off with this simple homepage. From here on, one can choose to just check the system out by directly going into the system demo page. Once in the system demo page, users need to wait until the AI model for object detection is loaded. After the loading of the model, video detection can be started using the Start button. In the system demo page, users need to calibrate their device to be able to measure distance accurately. Unsaved users will be prompted to calibrate their device every time they visit the page. If users are not logged in, their videos will not be saved and video data lost between every attempt. To calibrate user devices, we simply follow the steps in the instruction box. We will cover calibration once we have a registered user. Let's continue by registering a user first. After signing up, the users are automatically logged in and taken to the dashboard page. In the dashboard page, users can view previously saved videos by selecting a video from the list and clicking the load button. Once loaded, the video is going to be displayed in this window here, and related data, which will be dynamically loaded, will be displayed in this section. Users can also see other information such as number of videos saved here, number of devices calibrated, total space used, and users are given as a free subscription by default. Since John is a new user, he does not have any videos saved previously. Let's calibrate our device and save some video. Once we move to the system demo page, we wait for the model to be loaded. Then, to calibrate the device, we follow the 10 steps listed here. For the first step, we turn on the camera. Then we select a known distance to be stood away from the camera. In our instance, this distance was 0.9 meters. For user privacy, the camera capture has been blurred. Once this is entered, we observe the screen for the width of the detection box and entered that in step 6. We then click Calibrate to calculate the device calibrations and save it as a user device. After the first calibration, we can see the distance near the top of the bounding box. Check the distance for reasonable accuracy and recalibrate by following steps 2 to 7 as required. Once done, we turn off the camera and click Calibration Done. After user device calibrations have been saved, users can record videos which will be automatically saved in the database. While recording videos, users can also see live graphs from the video data. The first graph shows the number of objects detected. The second graph shows how many incidents have occurred per frame of the video clip. An incident occurs when detected objects in the video break the distance maintaining guidelines. The threshold of the distance can be set using the input field here. Lastly, the last graph shows distance between the first two objects over time. If more than two objects are detected, graphs of additional detections can be seen in the dashboard when the video is loaded again later. Since in this video capture there was only one object detected, the graphs for the distance has not been filled, and the incidents remain at 0 and objects detected at 1. To stop the video recording, simply click Stop and inspect the progress bar for progress updates. To record more videos, users can simply refresh the page and start new. After video recording is done, users can go back to their dashboard to open and play previously saved videos and also see associated data graphs. Simply click on the video name and Load button. Video data graphs are also loaded with the video and shown in this section here. The sidebar also shows the updated information. When done, users can simply log out of the system. This was a simple demo of how a new user would use this system. Here is an example of another previous user who already has some videos saved with some more data and additional graphs. As can be seen here, the graphs will be dynamically generated depending on the number of objects. Thank you for taking the time to learn about our system.